Hi everyone, in this video we're just going to have a quick look at some techniques to help debugging. In many of the exercises that you'll be doing in this course, you'll be using pointers and different types of pointer arithmetic to build up complicated structures. Often if there's a problem with these pointers, you can end up with something called a seg fault, which means you've tried to access memory that didn't belong to your program. And those kind of bugs can be very difficult to track down, particularly given that the C++ environment doesn't give us a useful error message. It just says a segmentation fault. So it would be useful for us to have some kind of system that can tell us exactly where the problem is. So as a first example, we're going to write some code that just prints out an integer using a function. So we're going to create a file. We're going to add in all our normal C++ headers. IStream allows printing. We're using the standard namespace, and we're going to have our main function. So there's our main function as normal. We now want to create some integer. We'll call our integer a, and then we want to create some function that prints it out. So let's go void fun, and that will take in a pointer to an integer. So int star, and that's going to be our pointer. And then inside the function, we're going to print it out by dereferencing the pointer. Then over here, we can create a pointer to an integer as well. And in this case, we'll set it to the null pointer. If we call fun of a, that over there, we're passing an integer where it's expecting a pointer. So in this case, the compiler won't compile because we've given it an integer and it's expecting a pointer. So when we call G++, that's the compiler, we're giving it the standard C++ 11 flag. So it's using C++ 11 instead of older versions. And then we're giving it the file we want it to compile. And we see that it gives us an error because it won't convert from an integer to a pointer, which is correct. So in order to fix that bug, we can use the ampersand sign in front of a, and that gives us the address of a. So now we're passing it a pointer. We make that update and save, and now when we compile, we see that our program works correctly. So in this case, it prints out the integer. If we then add on and we say, okay, cool, now we want to print out our next integer. So we can now say fun of b, and now we're passing in a pointer, and so that's all right. So the compiler will allow it. So when we compile that, we see that it doesn't complain. So in this case, we're passing b, which is an int star, it is a pointer, and so the compiler will definitely allow that to compile like that. But once we run it, we see that we have a problem. And in this case, the problem is quite obvious. We can see that that pointer isn't actually pointing to an integer, it's pointing to null, it's pointing to nothing. And so when we try and dereference the null pointer, we're going to get a segmentation fault. This can also happen when we try to dereference a pointer that we haven't initialized, or a pointer that has some garbage value in it, and we try to access memory that doesn't belong to us. So in this case, it's fairly easy for us to figure out where the bug was, but in general, when you have large programs, it can be quite hard. So I'm going to show you a trick called a debugger. So when we compile, instead of using the normal compile string like this, we're going to add in -g as well. And that tells the compiler to compile with the debug symbols inside. And then when we run our program, instead of just running the program as normal, we now run it through something called the debugger, GDB. So we go GDB of the file, like that. And then once we're inside the program, we can see that GDB has started up. It gives us a little prompt. Inside that prompt, we can now just type run, and then we hit enter, and we see that the program then runs, and it tells us that it's found a segmentation fault, and it can tell us exactly which line that segmentation fault happened at. So in this case, we can see it happened at line 6, and so if we go back to our code, we can see that line 6 corresponds to that exact same line as well, and it shows us exactly where the invalid reference came from. So we see at this point that we were trying to dereference PTR, we were trying to dereference that pointer, and at this point we can see that pointer was 0. Usually 0 means null. That's what it gets translated to in the back end. And so we can see that we were trying to dereference the null pointer. The real question then becomes, how do we track back where that came from? And we can use a command called bt, and that will show us all the functions that were called so far. So this is called the call stack, which we'll learn about more in class. But we can see that we started with the main function, and then at line 14, the main function called fun. And so at line 14, we then called the fun function, and at that point we passed in a null pointer, and then at line 6, that was where our program stopped. So we can see now that the problem probably originated at line 14, and we were passing in B, and so B was the null pointer, and so we can guess that that was probably the problem. And so if we go back, we can then change that, and we can say now that actually points at something, and then we can recompile. So in order to exit GDB, we can type quit and then yes, and then we can compile again. And now this time when we run our program, we'll see that it doesn't crash. So this allows you, so this program called GDB is a very powerful tool. It allows you to look at the values stored inside variables. You can step forward and backwards through your program, one instruction at a time, and it allows you to do a lot of things that are very helpful. The one difficulty is that it's a command line tool, and so it requires that you learn a bunch of the commands off by heart. And so we'll see now that there are a number of nicer interfaces that we can use instead of that. So one really nice interface that we can use for programming in general is called QtCreator, and it's an IDE, or integrated development environment, that allows us to program, and it has some nice tools for us. So what we can do is we can start a new project. In this case, it's a non-Qt, and we're just doing a plain C++ application. And so we can choose that, and we can give it a name. And so we're going to say bug. That will be the name of our project, and then we can just pick all the default versions for now, and we can see that it gives us a hello world program to start with. We can see that on the left pane it's giving us a list of all the different files. The .pro file just gives you some settings for the main project, and so we don't really need to worry about that, but we can see that it's using C++ 11 and that the files that it's going to compile with is main.cpp. Over here we can see it's included iostream in the standard namespace, which we can use for printing. We've got our main function, and then it's just added in a hello world application. And so if we go Control R, that will compile our program. Otherwise we can click on the little play button over here on the left, or Control B, which will build it. So if we do build, we can see the compile output. It gives us all our output there, and that's what the normal debugger would get, the normal compiler would give us. And so we can see that it compiled fine and there were no problems. That's it compiling the file, and that's it linking it afterwards. And then if we click the run button, we can see it launches a terminal and runs the program. So I've copied the text from our previous file and I can paste it here. And now we can see all our code as before is over here. We can see some nice features of the IDE. If I start typing and go Control Space, we can see that it gives me a drop-down box, and it's given me a list of all the other functions that already exist, and so that can also make things a little bit easier to work with. If we go back here and let's reintroduce the bug that we had earlier, so we're going to set that to the null pointer. Now if I go Control B, it will build it, and we see it built it without any errors. And if I go Control R or click on the run button, we can see this time it runs, it gets to 42, and then in this case we hit our seg fault, but the program didn't, it didn't tell us that the program crashed. So that's one thing just to watch out for. So rather, when you're busy coding, you should rather run the program in debug mode, which is the second button over here, or you can run it by pressing F5, and that will start debugging. If we press F5, we'll see that then the program launches. Here it is. So the program launched, it printed out our 42 as expected, and then when it hit the next line, we got a segmentation fault, but QtCreator detected that there was a seg fault and stopped the program. So when we click OK, we can see once again it's telling us that it was on line 6, so there's the little arrow over there telling us where the problem is, and we can see the problem was there. We can also see on the right hand side, we can see the values of all our variables so far. So in this case, we've got a variable named PTR. It's of type int star, and its current value is 0, which corresponds to null. So if we hover over, we can also see the value of that pointer. So here we can see again, that's where our program crashed, because we were trying to dereference an invalid pointer. And then if we look down here again, where we typed BT previously in order to see the call stack, now we can see the call stack at the bottom here by default. And so we can see that we were first in the main function, and on line 14 of the main function, we made a call to fun by giving it B, and then after that, fun ran, and then it crashed at line 6. So there's one more feature of a debugger that I would like to show you, and that's the idea of using things called breakpoints. So far what we've done is we've run the program with the debugger, and the debugger has just caught when there was a problem and it stopped the program. If we actually want to go in and investigate exactly what happened, then sometimes it's useful to stop the program before the bug happens, investigate all the variables, and then slowly step through each instruction one by one. So within QtCreator we can do that. If we go to where the line number is, and just to the right of it, you'll see that if we move the mouse, it changes from the normal cursor to the little hand. Once it's given us the little hand, we can click there and we'll see it inserts a little red dot, which means that there's a breakpoint there. From there, what we can do is if we press F5, it will launch the program. We can save any changes. It will now launch the program, and the program has started running. So there's the terminal. We can see that at this point it hasn't done anything, it hasn't printed anything out, and so that's where it stopped. The program hit the breakpoint, so before this line is run, the program stopped. The debugger stopped it. We can see the call stack, we're in the main function and we're on line 10. And if we look at the variables at the moment, we can see that this is what's currently stored inside all of them. So then as we go through, we can say, okay, we now want to run this line, and you'll see that there are these three buttons here. One that corresponds to step over with a F10 shortcut, step in, which is F11, and step out, which is Shift F11. When we say step over, it means execute the current line and move on to the next line. So it will run that, and then it will stop over here. When we say step in, then if we're calling a function, it will go inside the function. So if we were at line 13, for example, and said step over, then what that will do is that will run the fun function, and then it will stop when it hits line 14. If we said step in, then it would go into the function and we'd be able to have a look and see what happens inside the function. So in this case, it's just a normal expression, and so we're going to go step over, so F10, and we'll see now that line runs and the value of A is now 42. We're then on line 11, and so it's about to set the value of B to be the null pointer, and so we expect that value to change to 0. So if we go step over again, we can see that that's now changed, and it's correctly set the type and value of that variable. We're now sitting on fun, and so now we're on a function. So if we go step over, it will just go to line 14 after executing it. But let's go step in. So if we go step in, now it runs, it goes inside the function, and it's stopped on the first line inside the function, and we can see that the value of pointer as an integer is going to be 42, that it's pointing to something with the value 42. And so we can now step over, we can run that function, we can see it ran C out, and so it's now printed out our value of 42. We're now at the end of the function, and so it's just waiting for us there. If we go step again, it then resumes, so this function is now finished, and we're now on to the next line over here. So we can see A and B, we can see that these variables change according to whatever function we're in at the moment. We're now on B, we see that it's null, and so if we go step in, once again it's stopped at that line inside the function. We can then go step over, and as we go step over, it's going to try dereference the null pointer, which we can see it's a null pointer over there. And as we dereference it, we can see that it now picks up the segfault again. And so by following this kind of process, it means that we can investigate the variables as it leads up to a segfault or up to some kind of bug as well. And that can also be very useful when trying to track down where the problems are. We can insert and remove breakpoints wherever we want, and so we can add them on any of these things. And once we've hit a breakpoint and we've decided, okay, no, everything is fine, we can also just tell the system that we want it to continue, and that we do that by pressing F5. Obviously, in this case, we've hit the segfault, and so by telling it to continue, it will just end the program because the program has crashed. So using a debugger like this, particularly with a nice front end like QtCreator, it gives us all the details we need. It shows us exactly where our segmentation fault happened, and we can investigate which functions were called in the lead up to the crash and what all the variable values are at that point. So whenever you have a segmentation fault in the future, I suggest that you make sure to be either coding in Qt or that you recompile your code with the -G flag, and that will allow you to run it in the debugger, and it will show you exactly where your mistake came from, and hopefully by looking at all the variables and being able to see which line is causing the crash, you'll be able to figure out how to fix it.